Today we are going to solve this very interesting puzzle. It looks like a Sudoku, but it has only 7 rows and 7 columns. We have to place the digit 1 to 7 into each row once and into each column once. The number in the circle represents the product of 4 digits around it. And we are asked to solve this puzzle. You should probably pause the video and try on your own. It is quite challenging and time consuming. First of all, I'll label this as R1, the row 1, row 2,
row 3, row 4, row 5, row 6, and row 7.
Likewise, column 1,
column 2, column 3, column 4, column 5, column 6, and column 7.
The product of the 7 in each row will be equal to 1 times 2 times 3 times 4 times 5 times 6 times 7. That is 7 factorial. And note that 7 factorial is equal to 1, 2, 3, 4, 5, 6, and 7. The 2 is of power 1, 2, 3, 4. The 3 is of power 1 and 2. And the 5 is of power 1. And the 7 is of power 1. We should look at the column 4 and column 5. So C4 and C5. We have this 168. 168 is equal to 2 to the power 3, 3 to the power 1, and 7 to the power 1. 120, 2 to the power 3, 3 to the power 1, and 5. 84, 2 squared, 3 to the power 1, and 7. The product of all numbers in C4 and C5 should be equal to square of 7 factorial. Square of 7 factorial should be equal to 2 to the power 8, 3 to the power 4, 5 to the power 2, and 7 to the power 2. We compare the product of these 3 numbers and square of 7 factorial. And you'll see that 2 to the power 8 will be the same, and it is lacking of 3 and 5. Now, 168 will cover these 4 numbers in R1 and R2. 120 will cover the 4 numbers in R4 and R5. And 84 will cover the 4 numbers in R6 and R7. So the only 2 numbers not covered will be in R3. It must be either 35 or 53. So this is the first thing that we know. Next, we do the similar thing to R3 and R4. So for R3 and R4, 192. 192 is equal to 2 to the power 6 times 3. 60 equals to 2 squared, 3, and 5. 105 is equals to 3, 5, and 7. We use a similar trick, and we know that by the comparison of the product 2 to the power 8 done. This is 3 to the power 3, but we need to have 3 to the power 4. So we're lacking of 3 to the power 1. And 5 is done, and we're lacking of 7 to the power 1. And 192 cover the 4 numbers in C1, C2. 60 cover the numbers in C3 and C4. 105 cover the numbers in C5 and C6. So this means that this must be 37 or 73. And it's clear that no matter 35 or 53, there is a number 3 in R3. So this number in R3 and column 7 cannot be equal to 3. Therefore, it must be equal to 7. And therefore, this number in R4 and C7 must be equal to 3. Next, 105, it is equal to 3, 5, and 7. They are all prime number. So these 4 numbers must be 1, 3, 5, 7. Now, if let's say 3 is here, then we can't place the 3 anymore in any of these 4 places. So it means that 3 must be in R3, C5. And therefore, 5 should be in R3, C4. Now consider the number 105. It has a factor of 7. 7 cannot be here. Cannot be here because 7 is not a factor of 1, 2, 0. So 7 must be here. 5 cannot be there. And 5 must be here. And 1 should be here. Now we should consider to place the number 7 in C3 and C1. Now, for C3, 7 cannot be in R7 and R6, so possibly it will be here, and it's not a factor of 60 and 120, so 7 may be in R1 or R5. Likewise, in C2, it can be only in these two cases, and for C1, it can be these three cases. Suppose 7 is in R1 C3. Since 7 is a factor of 168, then there must be another 7 in R2. So this will mean that R1 and R2 already have 7, so you can't have 7 here. And this will contradict to C2 because you can't find any R1 in C2. This will be contradiction because we choose 7 to be in R1 C3. So this means that R1 C3 cannot have 7. And therefore 7 must be in R5 C3. Using the similar argument, 7 must be in R7 C1. There should be a 7 in either R1 and R2 when we consider C2. We look at C1 and C2. So 192 we already consider it is equal to 2, 6 and 3, 1. 36 is equal to 2, 2, 3, 2. So in C1 and C2, we use up all the even number. So for these 5 numbers, so we left with 3, 5, 5, 7. Okay, we left with 3, 5, 5, 7 to be placed into these 5 cells, and therefore we need to have an extra 1. 1, 3, 5, 5, 7. Now we consider R7C2. We can only choose either 1 or 5 because 3 and 7 are not factors of 20. Suppose we will have a 5 here. So what is remaining here will be equals to 1, 3, 5, 7. And we look at the C3. Since you have already a 5, so 5 cannot be in R7, R6. And since there's a 5 in R3, C4, 5 cannot be in R4, R3, R2, then 5 must be in here. And now we consider R1, R2, 168 is equals to 2 to the power 3, 3 to the power 1, and 7. 24 is equal to 2 to the power 3, 3 to the power 1. And together with the 2, 5, 1, 3, and 1, 7, then we're left with this number here that is equals to 2 to the power 2, 2 to the power 2 to make up 2 to the power 8, and 3 times 3, 5 done, 7 done. So if R7C2 is a 5, then R1C3 will be a 5, and therefore R2C3 will be a 12. That will be a contradiction. We can't place a 12 in here. And therefore, it means that this R7C2 cannot be a 5. Since it cannot be a 5, it must be a 1. And therefore, we left with 3, 5, 5, 7. Now we do the calculation again. The product of these two numbers in R1, R2 will be equal to 12. And 12 can be written as 2 times 6 or 2 times 4. 192, the power of 2 is equal to 6. If we take all the even number, 2, 4, 6, then this is power 1, power 2, power 1, that is only power 4. Then it can be only written as 2464. What does it mean here? It means that there must be 2 4, 1 2, and 1 6. 4 must be in R3 and 4 must be in R4. And therefore, for this R3C4, it is either equal to 2 or equal to 6. We can't choose the 12 as 2 6, otherwise they will be the same. And in this case, therefore, it's either 3 4 or 4 3. Now we look at C2. Since there's a 7 here, so this will mean that this must be 5 or 7, 5 or 7. And the digit 3 cannot be in R3, R4, and R6, and the digit 3 must be in R5, C2. And again, for 192, there must be 2 4, so there must be a 4 in this column. The number in R6, C2 cannot be 1, cannot be 3, cannot be 4, cannot be 5, 7. Then therefore, it can be only a 2. Since this is a 2, we consider the number 20, there should be a 10. So there will be 2 and 5. 2 and 5, there must be a 2 here and 5 there. And we look at the column C3. We sort of 1 and 6. 1 and 6. But in R3, we cannot put 1. That's why it must be a 6. And this is equals to a 1. And look at the number 60. 2 must be here. And come to the R3. This must be 2 or 4. But because there is a 2 here, then this must be a 4. And this is equals to a 2. And again, this is a 4. And this is a 6. Now we look at this 120. 120 is equal to 10 times 12. So the two numbers in C4 and C5 must be equal to 12. As we mentioned, 12 can be 2, 6, and 3, 4. But we can't use 3, 4 here. So it must be 2, 6. And since there's a 2, so 2 must be in C5 and 6 must be in C4. And we go back to the column C1. This can be either 1, 6 or 6, 1. And since there's a 6, so it must be 1 and 6. For this number 84, 2 cannot be placed in these 4 cells. So it means that this must be equal to 4, 3, and 7. It must be equal to 1, 4, 3, 7. Then we consider the number 3. In R5, there's a number 3. So no more number 3 in R5. And in C7, there's a number 3 in C7. So there shouldn't be any 3 in C7. Then we consider C6. For C6, the 3 must be either in R6 or R7. Otherwise, there won't be any 3 in here. Because 64 has only one factor of 3. So 3 must be either in R6 and R7. And it will mean that there shouldn't be any 3 in R1 and R2. But for this number 24, it is equal to 2 to the power 3 times 3. And you do not have a number 3, so 6411 or 6221. It's either 6411 or 6221. We can't choose 6411 because if there's 2 1, then you contradict to this C6. And therefore it must be 6221. 6221. Now we go back to this number 120. Since there is already 30, we left with a 4, so it must be 4 and 1, and therefore this must be equal to 3. And since this is equal to 3, so the 3 must be in here, and therefore 5 is here, and 5 and 7 here. And go back to this 24. 1 cannot be here, 1 cannot be here, therefore 1 is here. and this is 2, 2, and 6. So from R2, 1, 2, 3, 4, 5, 6, and 7. And this is 1, 2, 3, 4, and 6. 6 cannot be here, so 6 is here, and 4 here. And for this 84, we cannot have 7 in R7 and C5. So 7 must be in R6, C4. And for number 1, it can't be in R7, it can't be in C4, so it must be in R6, C5. Likewise for 3 and for 4. The remaining number is not too difficult. From R7, 1, 2, 3, 4, 5, and 6. 5, 6. Since there is a 6, so it must be a 6, and there must be a 5 and 6 here. Likewise for this, 1, 2, 3, and 4. 3 cannot be here, so 3 and 4. Then lastly, 1, 2, 3, 4, and 5. So 4 and 5. And finally, we solve the puzzle, and this is the answer. As usual, I prepare one question for you to try. This question is actually a question that I set about 10 years ago. This question is a lot more simple compared to the one that we just considered. Have a good try and check answer in the description. If you enjoyed this video, please like, comment, and subscribe. That's all for today's lesson. I'll see you again. Bye-bye.